Okay, so our project is on the role of AI on minimally invasive neural implants. So I'm a senior at Chantilly High School. My name is Anjali Adagarla, and while I was writing this research paper, I worked with a professor from Florida International University. His name is Dr. P.M. Raj. So here we're going to talk about what minimally invasive implants are, how they'd be used in clinical contexts, the headwinds for the greater adoption of neural implants, the role of AI in operationalizing them, and how the government can make neural implants safer and more effective. So minimally invasive implants are very small dust-like particles. They're the size of a grain of sand, and they're made to replace large pacemakers and electrical cables in the body. Basically, they'll record local signals from the brain to monitor conditions like epilepsy, seizures, and other conditions. And we can use them to control symptoms through electrical pulses. And a benefit of them is that major surgeries aren't required, but a minor one is still required to implant them in the brain. And they offer a solution for interfacing with the nervous system by enabling real-time monitoring, stimulation, and potential therapeutic interventions. By recording stimulating neural activity in real-time, neural dust opens new doors for understanding more brain functions. So they're used 4 different ways in clinical context. The first one is medical treatments, second one is neuroprosthetics, neuroscientific research, and brain-computer interfaces. So with medical treatments, they deliver targeted electrical stimulations, and through real-time monitoring capability, they provide precise intervention, and this helps patients with symptoms like epilepsy, Parkinson's disease, and dementia. And then for neuroprosthetics, they can restore sensory or motor functions by interfacing with the nervous system, and this overall enhances the quality of life for patients with motor disabilities. And for neuroscientific research, researchers are able to leverage the neural dust to study brain function by mapping neural circuits, investigating the underlying mechanisms of neurological disorders. And for brain-computer interfaces, they facilitate direct communication between the brain and the device, which enables individuals to control prosthetic limbs, computers, and other assistive devices using their thoughts. So some of the headwinds for the greater adoption of them are evolving them to maturity and improving the diagnosis of the condition. The second one is maturing the ecosystem for safety to operationalize them. And the third one is preparing the process and workforce to support this technology. And the last one is making it more affordable for patients. So the role of AI in operationalizing them is the first one being the accuracy of diagnosis. So we can gather the signals from multiple of these devices from many patients and use AI models to improve the accuracy of diagnosis. And the second one is therapeutic patterns. So with the signals from these devices, we're able to identify therapeutic patterns that can improve the condition of the patient. And the third one is remote configuration. And doctors are able to remotely configure the stimulation pulse of the device and understand the brain function better. And then the last one is proactive alerts. And AI models are able to predict the catastrophic conditions and proactively alert the patients by sending them texts and alarms to prevent the activity. And this is how the government can make neural implants safer and more effective with 4 different ways: financial support, regulation, consumer protection, and education. So for financial support, they can provide funding for research through grants. And the second one is making it more affordable through insurance, Medicare, and Medicaid. And the last one is encouraging private-public partnerships by working with universities and schools to research more and test the devices before they hit the market. For the second one, regulation, we need to establish regulatory framework and security and compliance to make sure all the rules are followed and the privacy of the patient is respected. And the last one is auditability of data to make sure that we can go back and verify the data for any mistakes. And for consumer protection, we need to enforce ethical standards on industry stakeholders as well as consumer data and privacy standards, so the implant isn't misused in any way and the patient's privacy is respected. And the last one is education. So we need to support professional training programs for healthcare officials to make sure they know how to use the implants and make awareness of implications to the consumer so they know what they're getting into, like the risks and stuff, before they actually use them. And the last one is education on insurance coverage for both the doctors and the patients so they know what they're doing. Thank you. Any questions?
I really missed the very initial 3 seconds of the presentation. What do you mean by neural dust? I mean, are you referring to a specific type of implant? Are you referring to something specific? Because no, we understand the general environment and ecosystem that surrounds human-computer interfaces, specifically neurological implants. But you're talking about neural dust.
So it's like a new technology. Yeah. It's like really small. That's what it refers to by dust. So they still
sorry, I cannot hear you back here.
So they're like, it's a new technology. It's just dust is referring to it being really small, so it can replace big pacemakers in the body, and then it doesn't require a big surgery because it's so small.
Is it self-contained though, or do you need some sort of power source to?
There's still wires and stuff, but yeah.
Who is making it?
I'm just researching them right now. They're not in the market yet. It's like in the testing phase.
It is a Neuralink working with that?
No, Neuralink is a metal that is the size of a coin that has, 1,000 different wires. It's not dust. I mean, we know what we're talking about when we talk about an implant. It's not dust that is ethereal that flies in the air, or do you blow it on people? So, I mean, tell us more about it, because I'm fascinated about this future of life, and so whatever you know, tell us more about what it is.
It's basically like normal implants. It's just a lot smaller. So there's only like a small device that you put in the body along with it that's connected to wires.
And are you doing this in a lab in your university?
I've only just researched it. It's not.
The professor, where's the professor? Is the Florida University. So the professor actually owns the material, and she has done the clinical research part of that. So I'm not sure it has wires, but it's wireless Internet of Things kind of thing, a small spec which goes inside. Most of his research is whether that material is compatible with the bodily fluids and the body organs itself. So he's doing that. As he's doing that, she helped him in talking with physicians to understand what are the clinical cases, and this research is the result of her primary survey, right? Talking to physicians, plus her own framework. She has put a framework, technology framework on it. So that's what it is.
Oh.
Yeah, like it's a graduate level of the work by high school kids. So,
right.
so congratulations.
Yes.
Lots of good things.
They're school kids. Oh, okay. So the professor is at which university? I may not have all the info on the handout. The professor
Florida International.
Florida International. Oh, okay. Now I can locate you somewhere in the map, not out there in the air. Okay.
Yeah. His name is somewhere in the presentation, right?
Yeah.
Florida International University. Okay, got you. Yeah, thank you. Oh, that's your mentor. Got you. Excellent. Thank you for clarifying that.
So he does research on bioelectronic packaging. So his research is, is this material compatible with the body?
Biological tissues. Yeah.
So it helps with Parkinson disease suffer, right? People have Parkinson can potentially
Right. And even epilepsy also, which is
Right.
dangerous, right?
yeah,
Okay.
has got a future.
So what do you want to do next with your research?
I just I worked with Seiju, and he helped me with the role of AI in it. That's about it.
But what do you want to do next? What's your next step?
Well, which college actually are you going?
I want to go to Virginia Tech.
Oh, Virginia Tech.
I'm sorry, it's too bad.
Yeah. You should stay at George Mason. George Mason
Oh, I'm sorry, yeah.
has more good at robotics.
I'm sorry, JP, should be.
I know the professors there, so I can introduce you.
He's over there in the corner.
Yeah.
Well, that's great though, congratulations.
Okay, you're a high school senior. Yes. Wonderful. Congratulations.
Yeah, you think she is like
I thought she was the
graduate
associate
student.
professor. I think I only saw
Professional.
associate professor. I said, isn't she young? And then she began talking about this futuristic thing. I said, wow, where is she?
She's actually rising senior. She hasn't gone to senior class yet. So.
Oh, okay.
Yeah.
Well, you're younger. I thought already like decide
No, not yet.
senior.
You're rising senior, right? Yeah.
Oh, wow.
Not yet. Yeah. Great.
This is great. Thank you very much.
Well, this concludes our afternoon session. I'd like to thank everybody.
We should all go and take a big picture in the big stage.
That'd be great, yeah. So I think in a couple minutes, we're gonna all meet upstairs and try to get a picture of this group. I'd just like to say thanks to everybody for coming out today to watch these wonderful presentations, and to the presenters, I'd like to say thank you guys for your time in putting this together. This is really a wonderful presentation for a number of reasons. You know, if you've been following the stock market, the NASDAQ, you've probably seen this week that it's been a little shaky. People are starting to get a little bit concerned that maybe AI isn't going to deliver on the promise. But I think, you know, we see some wonderful applications from robotics, you know, from material science, healthcare here, and we see it from the next generation of AI workers. We see, you know, the next generation of talent here. This has really been a wonderful presentation. So again, we're going to be meeting upstairs in just a couple minutes to get a picture. Thank you guys for coming out today.